Hi, this is Bhaskara Beeraka. Today our topic is Revolutionizing Telecom BSS with Go. So in this presentation, we will explore how Go-based solutions have enabled the telecom companies to handle the millions of transactions while achieving the significant cost saving and performance improvement. Join us as we share the practical insights and real-world implementation for the engineering team looking into the build the next generation telecom infrastructure. So what is the BSS? BSS is nothing but a business support system. In telecom industry, it's a kind of pyramid architecture like network layer and OSS layer on top of BSS layer on top of customer experience layer and kind of thing. Telecom industries, they have a link, which we have to translate to the digital using the Go programming and apply the microservice architecture and deploy in the cloud native, the digital BSS market landscapes. So 8.9 billion projected global digital BSS market value, market size by 2026. So they're expecting almost $9 billion in 2026. And the compound annual growth rate is almost 18%, 17.8%. And cost saving is 75% and 40% is operational reduction. So telecommunication BSS market is experiencing a rapid growth has provided a transition from the legacy system to a digital solution. This shift is driven by the increasing customer demands for the real-time services, the need for operational efficiency and competition from the digital native companies entering the space. The Go programming has emerged as a key enabler in this transformation, offering a performance benefit that translates directly to the business value through reduce the development cost and the operational savings. So when we are applying the transformation from the legacy application to the digital, so it's almost 75% cost saving and 40% operational reduction for the Telecom BSS. So Go programming language having a special features. Using these features, we can efficiently develop the transformation from legacy application to the digital. So high performance concurrency model and memory efficiency cross-platform supports. Concurrency model means Go routines for the efficient parallel processing. And memory efficiency to Go programming language having a special garbage collection features. And cross-platform support means it's compile once and execute anywhere. So Go's design philosophy aligns perfectly with the telecom BSS requirements. It's compile the natural delivery and performance needed for the high volume transaction processing while maintaining the developer productivity through the clean accessible syntax. The language is built in the concurrency model with the Go routine, and the channel provided a elegant solution for the handling the millions of simultaneous connections, a common scenario in a telecom environment. Additionally, Go's memory management and garbage collection minimize the resource utilization and making it ideal for always on systems. So that is what earlier we discussed. Go programming language having a special features like a concurrency model. It has to handling the parallel processing, concurrency programming kind of thing, and special garbage collections. So because of that, utilizing the resources very minimal. So when we are supposed to using the any resources, once that task is done, that resource immediately are released. So that's the microservice architecture in the telecom service independence. Each business function operates as a standalone service with its own data store and the API interface. This independence allows the team to develop and deploy the scale services without affecting the other components. So service independence, when we are talking about translating legacy application to, we have to, that BSS entire enterprise applications, we have to divide into the multiple services. So each services, it has a own data stores and multiple API calls or multiple API interfaces. Because of that, it is very easy to develop that services and deploy it individually, and development activity is very parallelly happening. So multiple services we have to develop, and resilience and isolation. Failures in one service don't cascade into the system. In the BSS side, we have a multiple services. Suppose any services is down, so it do not cascade throughout the system. So we can apply some patterns like circuit breakers or timeouts and a retry mechanism, ensure that overall system remains operational even when individual component fails. At the same time, target scaling. Resources can be allocated precisely where needed. High demand services like a billing or customer management can scale independently during the peak periods without overprovisioning. That's absolutely. So we no need to entire system to scale up something like that. So whatever the service on demand, that particular services only we have to scale up actually. So that is the targeted scaling. So the transition from the monolithic systems to the microservices has been transformative for the telecom operation. This architectural approach breaks down the complex systems into the manageable and specialized services that are communicating through the well-defined APIs. Go's small memory footprint and fast start time make it practically well suited for the microservice implementation, enable the rapid scaling in response to change the demand patterns. Performance metrics and benchmark. So a real world implementation of Go-based BSS solution have demonstrated exceptional performance improvement. For our legacy systems, our benchmark shows that Go implementation consistently our performance previous generations of telecom software across the critical metrics. The ability to handle the 2.5 million transactions per hour represents a 4 times of improvement our legacy systems, while the 99.99% uptime translates into just a minute of ODR, a critical requirement for telecom operation where service interruption to directly impact the revenue and the customer satisfaction. So using this transformation, so it has to improve the performances, almost 2.5 million transactions per hour. At the same time, using these transformations, our system downtime is very minimal per year. So almost 0.00001% of downtime per year. So almost your system is available 99.999%. Yeah, that's the here. So security implementation. Whenever we have a services, when we are developing that Go language with microservices and BSS applications. So each services have a multiple APIs. And those APIs communicating internal APIs or external APIs or third-party APIs like that. So in these cases, we have to provide the security for the API calls. So we have to use the authentication and authorization mechanism, implement the OSS 2.0 and implementing the availability token with the Ghost crypto package or secure identity management across the microservice. And data production. Data production is most crucial thing. So that's the reason we have to apply the encryption AES 256 algorithms. The data encryption why we need. Actually, we have a very sensitive customer data at the same time financial transaction data. We need to provide the data protection. Encryption at the rest and in transit using the AES 256 with the customer Go implementation optimization for telecom workloads. Threat monitoring. Real-time security event processing with the Go powered analysis in engines for the pattern detection. Compliance. Adherent ITU 805 standard throughout automated security control and the audit capability. So security is a paramount in a telecom BSS, which handles the sensitive customer data and financial transactions. Our Go-based security implementation leverage the language's performance to process the security event at an unprecedented scale while maintaining the comprehensive protection. Go standard library provides the robust graphic framework that we have extended with the telecom specific security modules aligned with the industry standard like ITU TX 805, ensuring the both regulatory and compliance protection against the evolving threats. So in this security implementation, so we have to provide the APIs security. At the same time, we have to provide the data protections. DevOps integration. DevOps integration is the most crucial part while translating from legacy application to the digital. DevOps integration, it's providing a very fast development. So continuous integration, automated build, quality assurance, deployment, and monitoring. So continuous integration is nothing but automated testing with the goes built in the testing framework. Automated build cross compilation for multiple deployment targets, and the quality assurance, static analysis and security scanning, deployment of blueprint deployment with canary testing. The monitoring real-time metrics and distributed. So in this DevOps integration, so the develop the code, and we have a automated execution of the journey integration test. After that, build the code actually, and that once that build is happened, then we have to deploy our services into the cloud natives, actually cloud platforms. At the same time, we have to check the quality assurance like sonar quality checks actually. Once we deployed and services running in the production, we have to monitor the services, whether the services is down or up, and the particular services, how much CPU time and how much memory it is occupied. These things also we can monitoring actually. So using that DevOps integration, each and every services, we can monitor it, and how much CPU and memory it is occupied actually, that we can monitoring it. And the entire deployment and build and deployment process, we can automate it actually. So DevOps practices are essential for realizing the full potential of Go in the telecom environment. Our integrated pipeline enable us to deploy the changes to production multiple times per day with confidence. Dynamically reduce the time to market for a new features. So when we are developing any new features, it's very less time we can deliver those things actually. And goes to compilation speed and comprehensive testing capability, make it particularly well suited for CI/CD workflows. The ability to quickly build, test, deploy, and changes has transformed how Telecom BSS evolves, enabling a continuous improvement rather than the infrequent high-risk updates. Overall, DevOps integration is the most crucial part and the translating from the legacy application to the digitals. Cloud native deployment. So containerization, orchestration, multi-cloud strategy, and the service mesh. So cloud native deployment model enables Telecom BSS to achieve the elastic scaling and the graphical distributions. Goes minimal runtime dependency, and the small binary size make it ideal for the environments with typically microservice required for requesting 15-20 MB of container space. So when we are using the Go programming language, what are the dependencies? It is very 15 to 20 MBs only for containers space occupation. And this containerization is one of the crucial part, and it is called as a Docker containerization. And that containers we have to convert as a Docker images. That images we can deploy into the higher environments. Because of that, we have to avoid the environmental basis discrepancies. Any issues, lower environment having a lot of issues. One environment to another environment, when we are moving to our code, so it has a lot of discrepancies. So to avoid those things, we can use the Docker containerizations. So our cloud native approaches has enabling to us achieve the 300% improvement in scalability with the system automatically expanding and contracting based on demand patterns. This elasticity is particularly valuable for the telecom operators dealing with predictable traffic spike during the network events or marketing promotions. Okay. So in this cloud native deployment, mostly we are using the Docker containerizations. Open source tools and frameworks. Using these open source tools and frameworks, so it's obviously reduce our cost. It's open source. So using that open source tool to start developing your activity. So you have to spend the only development activity. There is no license cost for the your tools or frameworks. So it is available on open source. Okay, we have to use those things, and we can develop our entire transformation from the legacy application to digital, and we can implement our BSS application actually. Okay, data access and storage. Some for war capabilities, cockroach for the distributed desk. Cockroach distributed means cockroach DB is nothing but NoSQL kind of things. Redis for caching with the Go Redis client. These tools provide the foundation for the data persistency with the performance characteristics required by the telecom workloads. So API development, Gin and Echo framework for the high performance REST API, gRPC for the internal service communication, and Open API for the documentation. Our API handling millions of requests with a millisecond latency. Observability, Prometheus for the metric collections, Jigger for the distributed tracing, and Grafana for the visualization. Complete observability has reduced the MTTR from hours to minutes for the production issues. Project structure, Go module for the dependency management and project organization following domain-driven design principles. Consistent structure has improved the developer onboarding time by 60%. The Go ecosystem offers a rich collection of open source tools that accelerate the BSS development. We have leveraged these tools to create the modular, maintainable code bases that reduce the service provisioning time by 50% while improving the code. So, using these open source tools and frameworks, so they are telling that we are leveraging these tools to create the modular and maintainable code bases that reduce the service provisioning time by 50%. Absolutely. So using these tools, we can provisioning time 50%. A real-time data processing. So a real-time data processing, nothing but a Kafka stream with Go consumer. Processing and enrichment, Go powered streaming processor analysis. This is an ML model with a Go inference engines. Action automated response through APIs. Real-time data processing forms the backbone of the modern Telecom BSS, enabling the intermediate insights and actions. Our Go-based stream processing pipeline handle the millions of events per second. From network performance metrics to customer interaction, all processed with minimal latency. These capabilities has transformed how telecom operators respond to the customer needs. With a AI-driven system, reduce the churn by the 45% through proactive interventions. The net promoter score improvements of 25 points demonstrate that the business impact of the technical capabilities as customer experience are more responsive and this real-time data processing, we obviously use that because it's millions of transactions. So we have local transaction mechanisms. There we have to apply this Kafka. It's nothing but a event-driven architecture. In the event-driven architectures, obviously each event triggering and based on that what transactions we have to roll back whatever the transactions rollbacks or tasks or rollbacks that we can using the Kafka streams actually. This is the real-time processing, data processing. So implementing your Go powered BSS transformations, start with the clear business objectives. When we are implementing your Go powered BSS transformation, so we have a clear business objective and define your services properly. And each services find a multiple APIs and those APIs with using the securities and that also more protect. And modular transformation. Begin with the bounded context that offer the high business value but a moderate risk. Gradually expand your Go footprints. Build a Go expertise. Investing in training and pair programming to build a solid foundations of Go skill with your engineering. Yeah, this is obviously so better to do with pair programming. Learn the Go programming language and understand the key features of the Go language. And whenever you develop any services, we have to apply these Go features, and especially there is a parallel processing. So this Go parallel processing is very effectively and provide the more performances. Measure and optimizing. Establish the performance baselines and continuously optimize based on your real world telemetry and user feedback. As we conclude, remember that successful BSS transformation combines the technical excellence with a strategic business alignment. Your journey to Go powered BSS should follow the clear roadmap that delivers the incremental value while building towards comprehensive modernization. By leveraging Go's performance advantages, embracing cloud native architecture, and implementing the DevOps practices, your team can achieve the remarkable performance improvements and cost savings we have discussed today. The features of Telecom BSS belongs to those who can deliver the robust, scalable, and secure systems, and co-provider ideally foundation for this the next generation of telecommunication infrastructure. So, as we discussed on previous slides, so Go provides a ideal foundation of this next generation of telecommunication infrastructure. So far, whatever the legacy system, so they are facing plenty of issues in the environmental wise or whatever it is, and performance wise or whatever it is. When we are using this Go programming language and translating into the microservice architecture, so definitely we have to see the dramatic changes and a lot of performance improvements. Thank you so much.